Okay, so in this video I'm going to go through the solutions to the exam that I uploaded last week. Make sure that you've done the exam before you watch this video, and as we go through it I'm going to tell you the marks for each part so you can mark it yourself insofar as possible. Now obviously a lot of things have changed since last week, so I just want you to be aware that the only things that we haven't really covered are the geometry and the financial maths, and other than that there's just a few bits and pieces, and for the most part we just need to do revision. So my plan for the next couple of weeks is we're going to do all of the geometry, and then we're going to spend a couple of weeks and we're going to do revision. The financial maths is a really difficult topic, and insofar as possible I'm hoping to be able to actually physically teach that to you in the weeks prior to the Leaving Cert. But we'll have to take it as it comes, because obviously it's very hard to tell. It's very hard for us to tell at the moment where the situation lies. But we will be covering the entire course, so don't worry about that at all. Now, I want you to have your completed test open as I go through all of these. For question 1, part A, there's 15 marks, and then for the second part of the question, there's 10 marks. This is what we refer to as the special case. I have 2x plus 1 over x minus 1 is less than or equal to 1. Now I need to find all the values in this case. What I need to do here is multiply both sides by the denominator to be squared. In other words, multiply both sides by x minus 1 to be squared. If I multiply both sides by x minus 1 to be squared, let's just see what happens. So if I'm going to multiply both sides by x minus 1 squared, the x minus 1 on the bottom and the left will cancel with one of the x minus 1s on the top. And I end up with just double brackets on the left and double brackets on the right. Which if we multiply it out, we get to this stage, where we have an x squared, an x, and a number. So you move everything to one side and you get the quadratic x squared plus x minus 2 is less than or equal to 0. Ultimately, that is the question I'm trying to answer. When is the quadratic the range of values of x for which this quadratic is less than or equal to 0? But in order to answer that, I need to be able to draw a sketch of my graph. So I let my quadratic equal to 0 rather than the inequality. Factorize and solve this, and the two values I'm getting are x equals minus 2 and x equals 1. That tells me that if I sketch this graph, I know that the points where it would cross the x-axis are at minus 2, 0 and at 1, 0. It's a plus x squared, which means that it's going to be a U-shape. And it would cross at minus 2 and at 1. And now that I've drawn my graph, I can refer back to this line. The question is when is the quadratic less than or equal to 0? It's less than or equal to 0 when it's on or below the x-axis. So in this case, I would say any x values between minus 2 and 1, the quadratic is below the x-axis. So I could fill that in. Minus 2 is less than or equal to x, which is less than or equal to 1. However, you need to notice that it actually tells you in the question x can't be equal to 1, but the reason x can't be equal to 1 is because if I subbed in a 1 for x, the denominator or the bottom of the fraction on the left would be 0. And that's undefined. We cannot have a 0 on the bottom of a fraction. So x cannot be equal to 1, so you have to eliminate the equal to sign there. You lose 5 out of 15 marks if you put in that equal to sign. So they tend to be very harsh with the last few bits of that question. And often things that have been catching a lot of you out all year have been finishing off the last few lines in one of these. Ultimately, this is my final answer and it's worth 15 marks. Okay, part B of question 1 was quite straightforward. I have a fraction divided by another fraction. In maths, we always want to avoid that scenario. Rather than having this fraction divided by this fraction, it's easier if you flip the second fraction and multiply. So all I've done is I've got the reciprocal of the fraction. What was on the bottom is now on the top, what was on the top is now on the bottom, and that allows me to change from a divide to a multiply sign, which makes my life handier in a moment. Then I realised I have a quadratic here which I factorised, I have a quadratic here which I can factorise, and I can take out what's common from the denominator. 5x plus 25, I can take out a 5. Now the reason I wanted a multiply sign instead of a divide is because now I can 5 will go into 5 once, x minus 7 and the x minus 7 will cancel, the x plus 5 and the x plus 5 will cancel. Which means that 5 went into 5 once, x minus 7 went into that once, x plus 5 went into this once, which means I'm left with a 1 on the top of my fraction, and the only thing I'm left with on the bottom is x plus 2. So your final answer is 1 over x plus 2. Again, I think a lot of students end up with 7 out of 10 on those questions because they don't finish off. You need to finish off and write your answer as 1 over x plus 2. Okay, in question 2, there was 10 marks going for part A and 15 marks going for part B. In part A, we're given 3 different diagrams. We have to identify whether they're bijective, injective, or surjective. Diagram 1 here, in order to figure out if it's injective or not, if it's injective, that means it's 1 to 1. That means that every x value will give you one y value, but every y value will only have one arrow going to it. So basically, every one of these functions, there's always going to be just one line coming from each input. That's the definition of a function. If it's injective, there's only ever going to be one arrow going to each y value. There's 5 dots here, and each one of them has a single arrow going to it. That means that it's 1 to 1. That tells me that it is injective. In order to identify if it's surjective or not, I need to identify is the entire codomain busy. Like if there was an extra dot out here that wasn't filled, then it wouldn't be surjective. This one is surjective because the entire codomain, all of the dots and all of the y values are being used, so that means that it's surjective. If it is injective and it is surjective, that means it's bijective. Bijective just simply implies that it's both of them. So the first diagram here is an example of a bijective function. In the second diagram here, this is an example of an injective function. I know that it is injective because each y value has one arrow going to it or none. If there are one or none going to it, then that's fine. It's as long as there isn't 2 arrows going to one of the outputs, it's injective. So in this case, we have an injective function, but it is not surjective. And the reason it is not surjective is because there is an element of the codomain that is not being used. There's a dot over here not busy, so that means it's injective but not surjective. And obviously if it's not surjective, that means also that it's not bijective. So the second diagram was an example of an injective function. In the third diagram, the entire codomain is busy. There are no elements in the codomain that aren't being used. That tells me that it's surjective. It is not injective because of what's going on here. I have an output coming from 2 different inputs. If I have 2 arrows going to the same output, then it is not injective. So it is surjective because the codomain is busy, but it's not injective because there's 2 inputs giving me the same output. So for diagram number 3, you just had to say that it was a surjective function. Question 2, part B, was a standard enough logs question. In this question, we're given a formula that models the number of bacteria that grow in a petri dish. We're told that at the very start, the teacher puts in 100 bacteria. Now that's vitally important. In these questions, you always need to figure out what is going on at the start of the situation. At the start of any situation, obviously that means that t is equal to 0. That's at the starting point, t equals 0. And I know that when t was equal to 0, the number of bacteria in the petri dish was 100. So I can sub in t equals 0 and n equals 100. That's going to allow me to find the value of the constant or. Once I have the value of the constant or, I can then try and get the value of the constant k, because there's a second piece of information I was given. The second piece of information I was given was that after 5 hours, there are 600 bacteria in the petri dish. So I know that when t equals 0, I can sub in n equals 100. When t equals 5, I can sub in n equals 600. That's 2 pieces of information that will allow me to find the value of or and the value of k. So just if you struggled with this one, you gotta start off with what's going on when t equals 0 in these questions, because it makes your life so much easier. So let's just sub in and see what happens. If I'm subbing in this scenario, the left hand side will become 100, the right hand side will be or e to the power of 0. Obviously if it's k times 0, it's just 0. You should remember from your powers that any number to the power of 0 is just equal to 1. So that means the right hand side I just have or times 1, which is just or. And or works out as 100. So that actually changes the formula. From here on out, I can now view the formula as if n is equal to 100e to the power of kt, because or is not a variable, it's a constant. So now that I know what or is, if I sub in this piece of information, the only unknown I'm going to have is k, and I'll be able to find the value of k. So let's sub in. The left hand side, if I sub into the formula, would be 600. The right hand side will be 100 times e, and the power will be k times t, which is 5. I now have one equation and one unknown, which means I can find the value of k. At this stage, I would expect you to recognize that the unknown is in the power, which means we're going to be introducing logs. But before you introduce logs, you have to isolate the term with the unknown in the power. Or in other words, I need to isolate the e to the power of 5k. So what I want to do is divide both sides by 100. If you divide 600 by 100, you'll get 6. And if you divide the right hand side by 100, the 100 is just gone and you've e to the power of 5k. And now I've isolated the bit that has the unknown in the power, so I'm going to introduce logs. The easiest log to introduce is just the natural log, which we represent as ln. So I get ln 6 is ln e to the power of 5k. And the reason that we're introducing logs is now we can apply the rules of logs. On page 21 in your maths tables, it tells you that if you've log of something to a power, you can just bring the power in front. So it just becomes 5k ln e. Now, the whole point of the logs was to get rid of the powers. This is the first line where I don't have a power, so this makes my life a lot easier. You should remember that ln e is just 1. Log e to the base e is just 1, so I'm left with 5k is equal to ln 6. And in order to get k on its own, I will divide both sides by 6. And I can just say here that k is equal to ln 6 over 5. I'm just going to plug this into my calculator and get my final answer for k. When you plug it into your calculator to 4 decimal places, your answer should work out as 0.3584. And that gives you the full marks for part B. Okay, question 3 was significantly more difficult. Question 3, there are 3 parts to it. You get 10, 10 and 5. So the first part of this question, you were given 3 to the power of 2x plus 2 minus 28 times 3 to the power of x plus 3 equals 0. And you were asked to solve to find the values of x. They gave you a hint, they told you to use substitution. Instead of 3 to the power of x, you can sub in a y. If I do that, let's look at what would happen to the middle term. The middle term will become minus 28y, and the last term is obviously just the 3. The problem lies in figuring out what to do with 3 to the power of 2x plus 2. Now, students often try and just do this in their head. It's not a good idea, you should drag it out. So I have 3 to the power of 2x plus 2. And I want to split this up some way. You want to strip it down. You don't want a 2x, you want a 1x. So instead of writing 2x, I'm going to write this as 1x plus 1x plus 2. 2x plus 2 is the same as 1x plus 1x plus 2. Now, on the top left-hand corner of page 21 in your maths tables, it tells you that a to the power of p plus q is the same as a to the power of p times a to the power of q. Based on that, I can say that 3 to the power of x plus 2 is the same as 3 to the power of x multiplied by 3 to the power of x multiplied by 3 to the power of 2. And this is useful because I decided at the very start of this question that instead of 3 to the power of x, I'd sub in a y. So I can now say that this, instead of this 3 to the power of x, it's a y. Instead of this 3 to the power of x, it's a y. And 3 to the power of 2 is 9. So I started off with 3 to the power of 2x plus 2, and I've broken it down now to 9 times y. Or in other words, 9y squared. And now I'm in familiar territory, I just have a quadratic equation. So you can factorize this quadratic whatever way you're used to factorizing. The factors of 9y squared are 9y and y, 3 and 1, and both will be minuses. So my factors will be 9y minus 1 times y minus 3. I can now let each factor equal to 0, and I should be able to get a value for y. Ultimately here I get y equals 1/9, or else I get y is equal to plus 3. Now, you're on 7 out of 10 at this stage. Once I've found values for y, I need to go back on my substitution to find the corresponding values for x. I know that y is equal to 3 to the power of x, and I know that y is equal to 3. That tells me that 3 to the power of x is equal to 3. If 3 to the power of x equals 3, obviously the right hand side, that's actually just 3 to the power of 1. The 3's cancel, and I'm actually just left with x is equal to 1. So that's my first answer, is x equals 1. And I'm going to do something similar for this one, for y equals 1/9. It's just going to be a little bit harder. I can say that 3 to the power of x is obviously equal to 1/9. Now another way of writing 9 is 3 to the power of 2. So I could say that 3 to the power of x is equal to 1 over 3 to the power of 2. Now if you go to page 21 in your maths tables again, it tells you that 1 over a to the power of p is equal to a to the power of minus p. In other words, if I have 3 to the power minus 2 on the bottom, it changes sign when it goes up. A to the power p on the bottom becomes a to the power minus p. If I have 3 to the power 2 on the bottom, that becomes 3 to the power minus 2. You just change its sign. So in fact, 1/9 is the same as 3 to the power minus 2. I can now cancel my 3's, and my second answer is x must be equal to minus 2. So you get 10 marks there for x equals 1 and x equals minus 2. Okay, so in part B, we were asked to prove by induction that the sum of the squares of the natural numbers is equal to this. The first step that we always do in induction is we try and prove that P of n, the proposition, is true for n equals 1. Remember that if we're dealing with a series on the left-hand side, the thing that is variable is the number of terms. So if n equals 1, the number of terms on the left-hand side will be 1. It'll literally just be the first term. And I know that the first term, it's written there, it's just 1 squared, or if I subbed into the general term, it would just give me 1 squared. So the left-hand side is literally just a 1. Because n equals 1, that means there's only 1 term on the left-hand side. On the right-hand side, I'm simply going to sub in. I get 1 times 1 plus 1 times 2 times 1 plus 1 divided by 6. All I've done there is rewrite the fraction, except everywhere there was an n, I put in a 1. 1 squared works out as 1, and if you plug that into your calculator, it also works out as 1. So I'm happy enough with that. Obviously, this proposition is true for n equals 1. Now I need to make my assumption and go from there. I need to assume that P of n is true for n equals k. In the last case, n was equal to 1, which meant there was 1 term on the left-hand side. This time n equals k, and I don't know what k is. K could be anything. K could be 50, k could be 100. I don't know how many terms that I actually need to write out on the left-hand side. I know the sequence is going to start as 1 squared plus 2 squared plus 3 squared, and it's just going to keep on going on. I don't know how many terms are in the middle, but I know that the last one is going to be k squared. The last term, I'm just going to sub in, instead of n, I'm going to sub in a k. In the question that was given, n is your unknown. It's 1 squared, 2 squared, 3 squared, the whole way up to n squared. This time, just instead of n, I'm putting in a k. So I literally just rewrite the left-hand side exactly as it was, except instead of an n, I put in a k. And on the right-hand side, everywhere there's an n, I'm going to put in a k. I'm going to assume that all of this is equal to k times k plus 1 times 2k plus 1 divided by 6. And that's my assumption, highlighted because it's impossible to finish the question without coming back to there. The third step, I need to prove that P of n is true for n equals k plus 1. Okay, now I want you to think about this. Let's pretend that k was 20. If k was 20, then what I've actually written on the left-hand side is 1 squared plus 2 squared plus 3 squared, the whole way up to 20 squared. Now I'm subbing in k plus 1, which in this, that means now I have 21 rather than 20. So I'm gonna rewrite exactly what I had here, which is one more term. Instead of having 20 terms, I'll now have 21 terms. Basically, my point is, if that was n equals k, this one is k plus 1. So it's exactly the same as my assumption, and then just one more term at the end, because there's one extra term. So I know that if I'm trying to sub in n equals k plus 1, I would start with 1 squared, 2 squared, 3 squared, and I would keep on going to k squared. So basically I've just written exactly what I had up here, and then you add in your next term. There'll be one more term, and the last one will be k plus 1. You're subbing k plus 1 into the general formula here, so my last term would be k plus 1 to be squared. If k was 20, then there'd be 20 terms in this, and there'd be 21 terms in this. The right-hand side, as always, is quite straightforward. Instead of n, I'm going to put in k plus 1. Instead of n plus 1, I'm going to put in k plus 1 plus 1. And instead of 2n plus 1, it's going to become 2 times k plus 1 plus 1. And I divide all of that by 6. Now, this is the important bit. I purposely rewrote the left-hand side of my assumption. I purposely rewrote it exactly as it was. Because from my assumption, I know that 1 squared plus 2 squared plus 3 squared the whole way up to k squared is equal to this. I have 1 squared plus 2 squared plus 3 squared the whole way up to k squared. So instead of what I've underlined, I can sub in the right-hand side of my assumption. It becomes k times k plus 1 times 2k plus 1 divided by 6. Then I have one more term, I have the extra term that I added on, which is k plus 1 to be squared. If I simplify the right hand side, I have k plus 1. The second bracket is k plus 1 plus 1, which is going to become k plus 2. And in the third bracket, I have 2 times k plus 1, which is going to become 2k plus 2. And then I also have a plus 1 at the end. And I divide all of that by 6. The point is that at this stage, this is a really straightforward. This is just basic algebra. The series is gone. I just have a few fractions. From here on out, we just need to follow simple algebra and hopefully end up with the same thing on the left-hand side as on the right-hand side. So what I've done on the top line here is I've simply simplified my last bracket here was 2k plus 2 plus 1, which is 2k plus 3. What I decided to do on the next line was to multiply everything by 6. If I multiply the first fraction by 6, then the fraction is gone. If I multiply the second one by 6, it just becomes 6 times k plus 1 to be squared. And if I multiply the last one by 6, then the 6 is gone. Now you don't have to do it like this. I just find that for me it's the easiest way to do it. But as long as you end up with the same on the left and the right, then you're fine. What I also did was I multiplied k by k plus 1 and I got k squared plus k. I also multiplied k plus 1 by k plus 2 and I got k squared plus 3k plus 2. On the next line, I multiplied k squared plus k by 2k plus 1, and I got these three terms. I multiplied k plus 1 by k plus 1 and got k squared plus 2k plus 1. And I multiplied out my brackets. I have 3 terms in this one and 2 terms in that one. Now obviously I'm skipping my lines, but you should end up with 2k cubed plus 9k squared plus 13k plus 6. All I did on the next line was multiplied 6 by these 3 terms and got 6k squared plus 12k plus 6. I then grouped everything on the left hand side, all the like terms together, and I ended up with the same thing on the left hand side as the right hand side, which means I can conclude and say that it's true for n equals k plus 1. To get the full marks now, I need to just make my conclusion the 4th step in your induction. The 4th step is to write down my conclusion. I know the proposition is true for n equals k plus 1 if it is true for n equals k. So it's true for any number if it's true for the previous number. But I know that it is true for 1. So therefore it must be true for 2 and for 3 and for 4 and for 5 and for all of the natural numbers where n is an element of n. And that gives you your full marks for part B. There was 10 marks for that and then 5 marks for the next bit. In B part 1, we've proven by induction that the sum of the squares of the first n natural numbers can be calculated using this. And now we're being asked to find the sum of the squares of the natural numbers from 30 to 60. In order to do that, we first need to get the sum of the squares of the first 60 natural numbers. In other words, 1 squared plus 2 squared plus 3 squared the whole way up to 60 squared. And in order to do that, you simply sub in 60 instead of an n. And I got 73,810 for that. But I don't want to include 1 squared plus 2 squared plus 3 squared the whole way up to 29 squared. I want to start at 30 and then go to 60. So I also need to get the sum of the first 29 numbers squared. And I need to subtract it from the sum of the first 60 numbers squared. Because if I do that, I'm left with 30 squared plus 31 squared plus 32 squared the whole way up to 60 squared. So I get S60 and I subtract S29. And when I did that, my final answer was 65,255. And that gives you the marks for B part 2. Okay, for question 4, there was 10 marks for the first bit, 5 marks for the second bit and 10 marks for the third bit. In the first part of this question, they told me that z is equal to minus a half minus root 3 over 2i, and they asked me to write this complex number in polar form. Remember that to write a complex number in polar form, I need to write it in the form of or cos theta plus I sine theta. Or is the modulus and theta is the argument. It's really straightforward to calculate our modulus. It's just calculated as the square root of a squared plus b squared, where a is the real number and b is the coefficient of I. So if we sub in there, the modulus of this is just the square root of minus a half to be squared plus minus root 3 over 2 to be squared. And if you plug that into your calculator, your modulus works out as 1. It's far more difficult for us to work out theta, the argument. And in order to work out the argument, you should draw yourself a diagram. So I'm drawing myself an argand plane where the horizontal line represents the real axis and the vertical line represents the imaginary axis. And I'm just going to roughly plot where my complex number might be. The real value is minus a half, let's say that this is minus a half, and the imaginary value is minus root 3 over 2. So clearly my complex number is in the third quadrant. Again, your diagram is just to allow you to visualize what's going on. It doesn't have to be accurate. But I'm saying that this is where my complex number is. What I now need to do is I need to form a right angle triangle by joining my complex number to the horizontal line and then to the origin. And I've formed a right angle triangle here. What I'm concerned with at the moment is I need to find this angle. The angle that it's making with the horizontal line, let's call it the angle A. I have a right angle triangle. And clearly from my diagram I can tell that the distance from the origin to here is root 3 over 2. Or in other words, the distance from here to here would also be root 3 over 2. And the adjacent to my angle, the distance from here along the horizontal line is obviously a half. Notice that I'm ignoring my signs because I'm talking about distances. I'm not going to say the distance is minus a half. It's still a distance. Its absolute value is a half. So if you look at this right angle triangle, I'm looking for the angle A. I know the opposite and I know the adjacent. If you know the opposite and the adjacent, you can find the angle by using tan. In a right angle triangle, the tan of an angle is equal to the opposite over the adjacent. In this case, the tan of the angle is root 3 over 2 divided by a half. If you get root 3 over 2 and you divide it by a half, it just works out as root 3. So I could say the tan of the angle is the square root of 3. Now, if you get tan inverse of root 3, or if you go to page 13 in your maths tables, it's going to tell you that the corresponding angle A is 60 degrees. So that means that the angle in here, in this right angle triangle, is 60 degrees. But remember that that's not actually what we're looking for. We're looking for the argument. The argument is the angle that the complex number makes with the positive sense of the x-axis. So I want you to think of your trigonometry here. Think of your unit circle. To get a value in the third quadrant, we've already traveled 180 degrees and we continue on in. So just even visualize from your diagram, obviously 180 degrees would get me to here, and then I know it's another 60 degrees. So I needed the 60 in order to work it out. But ultimately I can say that my value, theta in the third quadrant, it's 180 plus 60, which is 240 degrees. So at the very start there, I said we want to write this in polar form, which is or cos theta plus I sine theta. We've worked out or is 1 and theta is 240. So I can now say that this complex number z in polar form is 1 times the cos of 240 plus I times the sine of 240. And that's your final answer for the first part of this question. The second part of this question is really, really important. We're told that w to the power of 4 is equal to z, and we're asked to work out the 4 complex roots of w. So I'm trying to find w, which obviously means in the equation I'm given I should try and get w on its own. If w to the power of 4 is equal to z, if I get the fourth root of the left hand side and the right hand side, I could say that w is equal to z to the power of 1/4. So ultimately I'm trying to find z to the power of 1/4. And that makes a lot more sense now that because they've asked me to get 4 complex roots, we know that anything to the power of a quarter has 4 possible answers. In part I, we worked out that z can be written as 1 times cos 240 plus I times the sine of 240. Now obviously we don't need to bother putting in the 1, but ultimately it means I want to get all of this to the power of a quarter. Remember that if you're getting something to the power of a fraction, there's going to be more than one answer. In this case, we actually need 4 answers, which means that before we apply the Moyers Theorem, we need to generalize our angle. Remember from trigonometry that if we're dealing with degrees, in order to generalize your angle, you add 360n. So it's actually going to be cos 240 plus 360n plus I times the sine of 240 plus 360n. The reason we're doing that is because it's to the power of a fraction. You only do that if it's to the power of a fraction. But ultimately now I'm ready to apply the Moyers Theorem. Usually I would get my modulus to the power of a quarter, but the modulus is 1 and 1 to the power of anything is just 1, so I don't need to worry about it. If I'm using the Moyers Theorem, I multiply the power by the angle. Multiplying by a quarter is the same as dividing by 4. So in fact, if I actually apply the Moyers Theorem on this line, I'm multiplying the entire angle by a quarter, which is just like dividing by 4. So 240 will become 60 and 360n will become 90n. So applying my de Moivre's theorem, I'm basically just dividing my angle by 4, becomes cos 60 plus 90n plus I times the sine of 60 plus 90n. And at this stage, I'm ready to find my values. I now need to sub in n equals 0, n equals 1, n equals 2, and n equals 3, and that will give me 4 different values, and I can write them in rectangular form, and that'll be my answer. So I've chosen to sub in 0, 1, 2, and 3. Remember, it doesn't actually matter what values of n you sub in. All I need to do is sub in 4 consecutive natural numbers. I could sub in 10, 11, 12, and 13, and I'd end up with the same answers. So it doesn't matter what values of n I sub in. If I subbed in n equals 0, my angle becomes 60 plus 90 times 0, so obviously just 60. I get cos 60 plus I sine 60, and my first answer is a half plus root 3 over 2i. If I sub in n equals 1, I get 60 plus 90, which is 150, and my answer works out as minus root 3 over 2 plus a half I. If you sub in n equals 2, 90 times 2 is 180 plus 60 gives you 240. We get cos 240 and sine 240, it gives me minus a half minus root 3 over 2i. And if I sub in n equals 3, 90 times 3 is 270 plus 60 is 330. Cos 330 plus I sine 330 becomes root 3 over 2 minus a half I. So there are your 4 answers, the 4 possible values for W. Okay, so for question 4 part B, I'm asked to prove that sine 3 theta is equal to 3 sine theta minus 4 sine cubed theta. You need to recognize this. There were 2 similar proofs that we did in complex numbers. In order to do this proof, you need to start off with a generic complex number in polar form to the power of 3. You need to start off with cos theta plus I sine theta to the power of 3. And we're going to expand this by 2 different methods. The first thing that we can do is we can simply apply the Moyers Theorem. If you apply the Moyers Theorem, it's a complex number in polar form to a power. You simply multiply the power by the angle. If I was applying the Moyers Theorem here, it would just become cos 3 theta plus I sine 3 theta. That's one way of expanding this. Another thing that I can do is just good old-fashioned algebra. You literally just multiply cos theta plus I sine theta by itself 3 times. Now we've done this a number of times in class, so I'm just going to give you the answer when you multiply it out. So the most difficult part of this proof is in fact actually multiplying cos theta plus I sine theta to the power of 3, multiplying it out. And when we do, we get cos cubed theta plus 3i cos squared theta sine theta minus 3 cos theta sine squared theta minus I sine cubed theta. You have that in your notes. We've done it once or twice in class, so just make sure that you're clear on where that's coming from. So I started off with a complex number in polar form to the power of 3. 2 different acceptable ways of multiplying that out. One of them is algebra, where you multiply it out like this. Another one is the Moyers Theorem, where you get cos 3 theta plus I sine 3 theta. So obviously these are equal to each other. They're just 2 different ways of expanding this. Now, at this point, you have to figure out which proof you've been asked. If you were asked to prove cos 3 theta equals something, then I'd be concerned with the real values. Because I've been asked to prove that sine 3 theta is equal to something, that means I'm concerned with the sine 3 theta. I know obviously I want to have a sine 3 theta in my answer. And on the right hand side, the only term with a sine 3 theta in it is the imaginary term. So I now know that I'm only concerned here with the imaginary terms. Because I'm trying to end up with a sine 3 theta, the only place I have a sine 3 theta is here. It must be including this. What I can do now is let the imaginary terms on the left equal to the imaginary terms on the right. I have 2 imaginary terms on the left. My second term worked out as 3i cos squared theta sine theta. My last term ended up as minus I sine cubed theta. I can let these 2 imaginary numbers equal to this, and it'll be relatively easy for me to get from there to here. So there's 2 imaginary terms on the left, 1 imaginary term on the right. What I could do now is I can just say that I'm dividing everything by I. Or in other words, I can just ignore my i's now. I'm trying to manipulate it so that the left-hand side is 3 sine theta minus 4 sine cubed theta. Obviously, my issue at the moment is the cos squared theta. In my answer, I want to have only sine thetas. Here, so I need to get rid of the cos. On the top right-hand corner of page 13 in my maths tables, it tells me that cos squared a plus sine squared a is equal to 1. If I isolated cos squared a in that scenario, it tells me that cos squared a is equal to 1 minus sine squared a. Or in other words, cos squared theta, I can substitute in 1 minus sine squared theta. So it's 3 times this times sine theta, and that's my first term. My second term, I have a minus sine cubed theta, and I know that that is equal to sine 3 theta. So all I need to do is simplify this out. My life will probably be made easier if I rewrite this. Rather than having the 3 in front of the brackets and the sine theta afterwards, it'll probably be easier to visualize if I just put them both in front. I could write this as 3 sine theta times 1 minus sine squared theta. 3 sine theta times 1 is just 3 sine theta. 3 sine theta by minus sine squared theta gives me minus 3 sine cubed theta. And then at the end here I've got a minus sine cubed theta, and it's equal to sine 3 theta. I just need to recognize now that the second two terms on the left hand side are like terms. I have minus 3 sine cubed theta and minus 1 sine cubed theta. Minus 3 minus 1 is minus 4 sine cubed theta. So I have 3 sine theta minus 4 sine cubed theta is equal to sine 3 theta. And that is what I was asked to prove originally. So you'll notice I skipped a couple of lines in the middle there where you multiply cos theta plus I sine theta by itself 3 times to get to here. It's definitely worth your while practicing it. And when you're looking at this one, it's worth your while practicing the other one. The other proof on the Leaving Cert course asks you to prove that cos 3 theta, and you're asked to prove cos 3 theta is equal to, and it's something similar to this. If you were asked for the other proof, up until this line it's the exact same. Except that what you would have done is you would have let the real term on the right equal to the 2 real terms on the left. And in order to get rid of the sine squared theta, you would have subbed in 1 minus cos squared theta. It's just slightly different, but we've practiced them. This is the third test that has come up in this year, so hopefully at this stage you're clear with it. Okay, question 5 was on differentiation, and it was relatively straightforward at first. There was 10, 10 and 5 marks going for the 3 parts in this question. The first one, you were given minus 2x squared plus 3x plus 12, and you were asked to differentiate it from first principles. So you should have started off saying f of x equals what you were given, and then you want f of x plus h. So I subbed in x plus h instead of an x, and I multiplied it out and got to this stage. So on this line I've simplified f of x plus h fully. What I want to do then is subtract f of x. Subtracting f of x, this becomes plus 2x squared, and each of these become minus 3x and then minus 12. So the x squareds will cancel, those x's and the 12s. And I'm left with f of x plus h minus f of x, which is minus 4hx minus 2h squared plus 3h. The next thing I want is all of that divided by h. If I divide h into each term, I end up with minus 4x minus 2h plus 3. And the last thing you want is the limit as h approaches 0 of f of x plus h minus f of x over h. You do not sub in h equals 0. There's an arrow going to 0, means h is approaching 0. It's getting really, really, really small, like infinitely small, to the point where it might as well be a 0. So you just think in your head, what would you do if h was a 0? If this was minus 2 times 0, it would just be 0 and you would ignore it. So in your head you're subbing in 0, but you do not write it down on the page, because h is not actually 0, it's just really close to 0. And your final answer works out as minus 4x plus 3. You will not get the marks in a first principles question unless you've written out each of these at least once. You need to have written out f of x plus h minus f of x, and then the whole thing over h, and then the limit as h approaches 0 of all of it. If I'm marking these, I usually take marks away from people because of the left hand side as opposed to the right hand side. Remember that you can look at the original question and you should be able to tell what your answer is. I can tell the derivative of minus 2x squared is minus 4x, the derivative of 3x is 3, and the derivative of 12 is 0. So I knew the answer before I even started. But obviously you don't get marks just for the answer, you get marked for the process. In B part 1, we were given f of x equals e to the power cos x, and we were asked to find the derivative f dash x. If you go to page 25 in your maths tables, it tells you that if you've e to the power of something, its derivative just stays the exact same. The derivative of e to the power cos x is just e to the power cos x. But then we must multiply by the derivative of the power. The derivative of cos x is minus sin x. So you could leave your answer like that, but I suppose it's tidier if you leave your answer as minus sin x multiplied by e to the power of cos x. So simply e to the power of something, just you rewrite the question. It stays the exact same, and then you multiply by the derivative of the power. Okay, in part B, we were asked to get the integral of sin x e to the cos x. This is what we refer to in integration as an antiderivative question. This is a direct continuation from B part 1. In B part 1, I started off with f of x is equal to e to the cos x. I differentiated it and I ended up with minus sine x e to the cos x. I'm now being asked to integrate sine x e to the cos x. There's no product rule in integration on the Leaving Cert course, so from the stuff that we've studied, it is impossible for you to integrate sine x e to the cos x. Unless we go backwards, unless we use B part 1. If the derivative of e to the cos x is this, I know that if I integrated my answer, I would end up back where I started. So if I just did the opposite, if I integrated my answer to B part 1, I would simply end up where I started. The integral of the answer leaves me back where I started. All I'm doing is I'm referring to a loop here. I started off with f of x. If I differentiate, I get this. If I integrate, I end up back where I started. So I could say that the integral of the answer, the integral of this answer is equal to the original question. Notice now what you are actually being asked to integrate. You need to integrate sine x e to the cos x. So obviously I don't want to have a minus in front of it. I'm just going to change the signs of both sides. If I change the sign of the left, the integral of sine x e to the cos x dx is obviously equal to minus e to the cos x. So all I've done is change the signs. Now, I want you to notice that I haven't actually integrated, I never actually attempted to integrate sine x e to the cos x. However, I do have an answer. I know that if I integrated this, I would end up with minus e to the cos x. And now I just need to sub in the limits and work out the answer. So I've been asked to integrate this using the limits pi over 2 to 0. So basically that means I'm going to sub in the upper limit, pi over 2, and then subtract and sub in the lower limit. So if we do that, the first thing I'm going to do is going to be minus e to the power of cos, but instead of cos x, it's going to be cos of the upper limit, and the upper limit was pi over 2. That's the first one. Then I'm going to put a minus between them, rewrite it, but sub in the lower limit. So if I rewrite it, it's going to be minus e to the power of cos times 0. Now, obviously your calculator needs to be in radians for this one. If you plug this into your calculator, minus e to the power of cos pi over 2, your answer is going to be simply minus 1. And there's a minus between them, and if you plug this into your calculator, your answer is actually e. Works out as 2.7 something something. It's a really awkward figure. In the Leaving Cert and in integration, it's often acceptable to leave your answer in terms of e. So in a question like this, if you plug that into your calculator, it's actually just going to work out as minus e to the power of 1. Rather than writing it as a decimal, you're actually better off to just leave it as e. Obviously I have a minus by minus, which gives me a plus. So my final answer would be minus 1 plus e. In integration, it is acceptable to leave answers in terms of e, rather than as an awkward decimal. If the question didn't specify and you left it as a decimal, you'd still be entitled to the marks. However, I think that in an exam situation, it is likely that they will suggest to you to leave it in terms of e. So I think that's probably the hardest thing that we did on integration that threw a lot of people off. The thing you were asked to integrate, based on the stuff that's on the Leaving Cert higher level course, it's impossible to actually integrate that. The only way you're going to do it is to go back to the first part of the question, which was differentiation, and go backwards. In these questions, your first line is always that the integral of the previous answer is equal to the original question. The integral of my answer giving me this, then you manipulate it round and you should be able to get to your answer. So that's all we had to do for question 5. Okay, and the last short question in this exam, there were 4 parts to it. 5 marks for the first 3 parts and 10 marks for the fourth part. The first one is very basic integration. You have to integrate 2x squared plus 4x minus 2. Remember that when you're integrating, you increase the power by 1 and divide by the new power. So 2x squared becomes 2x cubed divided by 3. 4x to the power of 1 becomes 4x to the power of 2 divided by 2. And minus 2 becomes minus 2x to the power of 1 over 1. If there's no limits, you have to add in your c. There were no limits given, so you have to add in your plus c. If you've forgotten your plus c, you're only entitled to 2 marks out of 5. You only get 40% of the marks in this question if you don't put in your c. And obviously your second term can be simplified, so you should leave your answer as 2x cubed over 3 plus 2x squared minus 2x plus c. And that's your final answer for the first part of question 6. In the second part of question 6, we have to integrate sine 3x minus cos 2x dx. According to page 26 in the maths tables, the integral of sine of an angle becomes minus cos of that angle, but then I need to divide by the derivative of the power. The derivative of 3x is 3. And according to page 26, the integral of cos x is sine x. So the integral of cos 2x will be sine 2x, and then I must divide by 2. There was a minus in front of it, so the minus stays there. Once again, there's no limits, so I have to add in my plus c. And there was 5 marks going for that one as well. Okay, in part B, the third part of the question, you're asked to integrate from 3 to 1 x cubed minus 8 over x minus 2. There's no quotient rule in integration, so we're not able to do that. What you needed to do first was to factorize the top. You needed to recognize x cubed minus 8 as x cubed minus 2 cubed. It's the difference of 2 cubes, and you should have learnt off your formula for x cubed minus y cubed. In this case, your x would be x and your y would be a 2. When you factorize x cubed minus 8, you should get x minus 2 times x squared plus 2x plus 4. And that's useful now because the x minus 2 on the bottom divides into the x minus 2 on the top. And now I'm just left with a normal quadratic which I can integrate. The integral of the quadratic is x cubed over 3 plus 2x squared over 2 plus 4x. I don't add in a plus c because there's limits involved this time. Because I'm going to be subbing in limits, I simplified it. 2 into 2 goes once. So I actually have x cubed over 3 plus x squared plus 4x. You then sub in 3 instead of an x, you put a minus between them, and then you sub in 1 instead of an x. When I subbed in the 3, it worked out as 30. When I subbed in the 1, it worked out as 16 over 3. So I get 30 minus 16 over 3. My final answer is 74 over 3. Question 6, part C, there was 10 marks going for it. In this case, you're asked to find the area between the curve y equals minus x squared plus 2x plus 3 and the x-axis. Remember that when you integrate, you're getting the area between a curve and the x-axis. However, I first need to figure out what limits do I want to use when I integrate. So the first thing I want to do is find the roots of the quadratic. So I let the quadratic equal to 0 and I multiplied across by minus 1 so that the coefficient in front of x squared would be positive. When I factorize and solve this, the roots were x equals 3 and x equals minus 1. And that's going to allow me to sketch my quadratic. It's a minus x squared, so that I know that it's this shape. It crosses the x-axis at minus 1 and the x-axis at 3. And the question is to find the area between the curve and the x-axis. And obviously it's between the curve and the x-axis using the limits 3 and minus 1. So if I simply integrate the quadratic, this quadratic using the limits 3 and minus 1, that's going to tell me the area between the curve and the x-axis from here to here. So now we can just carry out our integration. So if I integrate the quadratic, I get minus x cubed over 3 plus 2x squared over 2 plus 3x. Again, I have a limits, so I don't add in a plus c. I simplified it a bit. 2 into 2 goes once and I get x squared. The upper limit is 3, so I rewrote the whole thing with a 3 instead of an x, then a minus between them, and then I rewrote the whole thing again with a minus 1 instead of an x. When I subbed in the 3, I got 9. When I subbed in the minus 1, I got minus 5 over 3. So 9 minus 5 over 3 works out as 32 over 3. And since we're dealing with area, I would always suggest students put in units to be squared. They didn't explicitly give me units, so I'm just going to call them units to be squared. And that's your final answer for part C. Okay, in question 7, there's 5 parts, each of which are worth 10 marks each. The first one here was quite straightforward if you recognised how to simplify it. If you're asked to differentiate this one, the first one option is you could use the quotient rule. The quotient rule is available on page 25 in your maths tables. On the other hand, there's a far easier way of doing it. The easiest way of doing it is realising that x squared will divide into both of the terms on the top. X squared into x to the power of 5 is just x to the power of 3. X squared into 3x to the power of 3 is just 3x. So in fact, if I just simplify it before I differentiate, it makes my life a lot easier. You were allowed to use the quotient rule in this case, and it's not wrong if you did, but now I can just do it in my head. If f of x is x cubed plus 3x, then the derivative of f of x, remember when you're differentiating, it's the opposite of integration, so you bring the power in front and you decrease the power by 1. So it becomes 3x to the power of 2, and since this is 3x to the power of 1, when I differentiate it, I would just get 3. So f dash x in that case is just 3x squared plus 3. If you had used the quotient rule, you would have been expected to simplify it down and end up at this point. Obviously, it's a lot longer and more difficult if you have used the quotient rule. In part 2, you were asked to differentiate 2e to the power minus 2x. Well, the first thing I address is the constant at the start. There's a 2 here, and it basically has no implication in the question other than I just take it down, but nothing happens to it. Now, e to the power of something, I have to go to my maths tables. According to page 25 in the maths tables, if you differentiate e to the power of something, it just stays the exact same. So e to the power minus 2x is just going to be the derivative of that is just e to the power minus 2x. However, I then must multiply by the derivative of the power. The derivative of minus 2x is minus 2. So I'm going to multiply by minus 2. So the constant you just take down, e to the power of anything just stays the exact same, but then you multiply by the derivative of the power. Now I can multiply minus 2 by this 2, and I'll actually get minus 4 e to the power of minus 2x. And that's my final answer for the second part of question 7. Part B here was very straightforward. You're simply given a function, a cubic function, and asked to get its derivative. The derivative of f of x in this case is 3x squared plus 24x plus 36. And that's all you needed to do to get the marks there. So part C is a direct continuation from part B. In part C, you were asked to find the maximum and minimum turning points of f of x. We've already identified that the derivative of f of x is 3x squared plus 24x plus 36. Remember that the derivative of a function represents the slope. And in order to identify the turning points of a function, we have to identify when is the slope of the function equal to 0. The only times the slope will be 0 is at a turning point, when it's at the maximum point or the minimum point. So I let my slope, or in other words my first derivative, equal to 0. I realise that I can divide everything by 3 and I get x squared plus 8x plus 12 equals 0. When you factorise and solve your quadratic, you get x equals minus 6 and x equals minus 2. So the x coordinates of the turning points are minus 6 and minus 2. But I was asked to find the points, so I need to find the corresponding y values. In order to find the corresponding y values, we have to sub our x values into the original function. Work out what is f of minus 6 and then work out what is f of minus 2, and that will tell me the maximum and the minimum points. So when I sub in x equals minus 6, the corresponding y value is 10. When I sub in x equals minus 2, the corresponding y value is minus 22. So the answer to this question is minus 6, 10 and minus 2, minus 22. In a lot of cases in the leave insert, you will get the marks for just, if you're asked to find the maximum and minimum point, you'll get the marks for that. However, there have been a number of questions where they expect students to prove which one is the maximum and which one is the minimum. I want you to realise that this one has a y coordinate of 10, which means that it's 10 units above the x-axis. This one has a y coordinate of minus 22, so it's 22 units below the x-axis. Clearly this one is the minimum and this one is the maximum. I can tell by just looking at the y coordinates. However, in an exam question, if you're asked to find the maximum and minimum point, you should assume that you need to prove which one is max and which one is min. If I had been correct in your exams, if you had done this in class for us, you would not have gotten the marks. You'd get 7 out of 10 at this stage. In order to identify which is the max and which is the min, we need to get the second derivative and sub in the x values. So in order to ensure you get the marks in a question like this, you should get your second derivative. If I differentiate the original function twice, I get 6x plus 24. You sub in the x values of your turning points. The first x value I got was minus 6. And when I sub minus 6 into my second derivative, I get 6 times minus 6 plus 24, which gives me minus 12. Because this is negative, that means that's the maximum point. So I will say f dash dash of minus 6 is less than 0. Because when I subbed in the x coordinate, I got a negative value, that means that that x coordinate, that point corresponds to the maximum point. So minus 6, 10 must be the maximum point. What I then did was I subbed in the other x value, which was minus 2. I'm subbing it into my second derivative, so I get 6 times minus 2 plus 24. In that case, it works out as plus 12. This time it's greater than 0. If you get something greater than 0 when you sub the x value into the second derivative, that means that you're dealing with the minimum point. So minus 2 minus 22 is the minimum point. Okay, for part D, you don't have to draw a graph, but this graph should explain it. we're dealing with a plus x cubed, which is a plus x cubed has two turning points, and a plus x cubed starts as a u and then it starts as an n and then turns into a u. I know the maximum point is minus 6, 10, and the minimum point is minus 2, minus 22. So because one of the turning points is above the x-axis and the other one is below the x-axis, that means that the graph has to cross the x-axis 3 times. So it has to have 3 real roots. Now I don't know where the roots are, so I just drew a rough sketch, but I know for a fact the max point is above the x-axis while the minimum is below the x-axis. One of them had a positive value for y, one of them had a negative value for y, and that implies that the cubic crosses the x-axis 3 times and has 3 roots. To get the full marks in this question, you just need something along these lines, and you get the marks there. Okay, so question 8 once again was divided into 5 parts, and there's 10 marks for each one. 10 marks for the first diagram and the table, and then 10 marks for the other 4 answers. In this question, we're given a pattern made up of matchsticks in the shape of triangles. The first pattern had 1 triangle, the next one had 2 rows, and there was 3 triangles in the second row. The next one had 3 rows, and then there was 5 triangles in the third row. And the one you have to draw has 4 rows, and there should be 1, 2, 3, 4, 5, 6, 7 triangles on your bottom row. 5 in this one, 3 in this one, and 1 in that one. So you get the marks there for drawing a diagram like that. So in the second part of the question, you're asked to fill in the table indicating the number of triangles and the number of matchsticks in each of the patterns. The first pattern is 1 small triangle, then 4, then 9, then 16. And in terms of matchsticks, you have 3, and then 9, then 18, then 30. That's just simply a matter of counting up the matchsticks and counting up the triangles. In part B, we're asked to write as an expression the number of triangles in the nth pattern in the sequence. If a question says write or write down, that implies you shouldn't have to do any work. You should just literally look at it and you should be able to tell. I can see that the first pattern has 1 triangle. The second pattern has 4 triangles. The third one has 9 triangles. The fifth one has 16. You should realize that all we're doing in each case is squaring that number. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. The next one would be 25, the next one would be 36. I want to know what would the nth one be. If there was n, pattern number n will have n squared triangles. So that's all we're looking for. We could say Tn, the number of triangles in the nth pattern is just n squared. You don't have to use the terminology Tn, you could just say n squared, but that's usually the way we'd write it. In part C, we were asked to work out how many matchsticks are needed to turn the n-1th pattern into the nth pattern. Now this is the only difficult part of this question. How many matchsticks to turn the n-1th pattern into the nth pattern? So that is making my life very hard. I need to turn the n-1th pattern into the nth pattern. How many matchsticks are required to do that? So I want you to think about a few things. Let's imagine that n equals 1. If n equals 1, obviously that's where we'd start off. We'd start off with n equals 1, and that will tell us what the first number in this sequence is. If n was equal to 1, then n minus 1 minus 1 would give me 0, and n would be 1. So if the very first one in this series is how many matchsticks are needed to turn the 0 pattern, before we even start, into the first pattern. Imagine what would happen if I subbed in n equals 2. If I sub in n equals 2, it's 2 minus 1. 2 minus 1 is 1, and then n would be 2. So the second thing in this pattern is how many matchsticks are needed to turn the first pattern into the second pattern. And then if we keep going, how many matchsticks are needed to turn the second pattern into the third pattern? If I subbed in n equals 4, they're asking me how many matchsticks are needed to turn the third pattern into the fourth pattern. The fact that the terminology they've used is n-1 into nth, that means that the first one in this series is the number of matchsticks needed to go from the 0 pattern, or before you've got anything, to the first pattern. And then from the first pattern to the second pattern, second one to the third one to the fourth one. Let's see what that means in the context of what we have. Obviously, before we started at all, there was no matchsticks, okay? But in order to get to the first pattern has 3 matchsticks. So obviously, to go from the 0 pattern to the first pattern, we must have added 3 matchsticks. There was none, and now there's 3. In order to go from the first pattern to the second pattern, we went from 3 matchsticks to 9 matchsticks. So obviously what we did was we added 6 more matchsticks. In order to go from the second pattern to the third pattern, the second one to the third one is from 9 matchsticks to 18 matchsticks. Obviously what I've done there is I've increased it by 9. So the third number in this sequence is adding 9. Now I'm looking for how many matchsticks are needed to go from the third one to the fourth one. Clearly to go from 18 to 30, I would have had to add 12 matchsticks. So the first number in this series, and the first one when n equals 1 is 3. The second one when n equals 2 is 6. The third one is 9. The fourth one is 12. So that was a really complicated and long-winded way of asking you to come up with a general formula for this sequence. The sequence is simply 3, 6, 9, 12. The first one is 3, the second one is 6, the third one is 9, the fourth one is 12. You should recognize that all we're doing is multiplying whatever our n is by 3. If n equals 1, 1 by 3 gives me 3. 2 by 3 gives me 6. 3 by 3 gives me 9. 4 by 3 gives me 12. So once again, I can just write down what this series is. The series they're talking about here, we could just say Tn is equal to 3 times n. Whatever n is, then the number of matchsticks, it's just 3 multiplied by n. And that's all you needed for that question. That is a very tricky. The wording they used in that one, I think, really catches students out. Okay, in part D here, we're no longer talking about the same sequence as we were in part C. We're now just talking about the number of matchsticks. We're told that the general formula for the number of matchsticks is an squared plus bn. We need to find the values of a and b. Now there are a couple of different ways of doing this. I'm going to do this one by a simultaneous equation. I know that the first term in this pattern has 3 matchsticks. The second one has 9 matchsticks. That's enough information. That's 2 pieces of information. That's enough for me to find the value of a and the value of b. I know that t1 is equal to 3. And I know that t2 is equal to 9. Now, that's the terminology we're used to using. But the un, if that's just, u is just another way. So rather than calling it t1, I'm going to call it u1. u1 is 3 and u2 is 9. It really doesn't matter, but I just want you to realize that instead of using a t here, they're using a u, which sometimes they're interchangeable. So I know that if I sub in n equals 1, I can let the whole thing equal to 3. And if I sub in n equals 2, I can let the whole thing equal to 9. I'll have 2 equations and 2 unknowns, so I'll do a simultaneous equation to find a and to find b. So let's just sub in. If I do that, it will become a times 1 squared plus b times 1. If I sub that in, I can let it equal to 3. Because the number of matchsticks in the first pattern here is 3. If I just simplify that down, I just get a plus b equals 3. That's going to be the first equation in my simultaneous equation. Now to get the second one, instead of subbing in a 1, I'm going to sub in a 2. It's going to become a times 2 squared plus b times 2 is equal to 9. And if I just simplify this one, 2 squared is 4, so I'll get 4a plus 2b equals 9. And that's my second equation. All I need to do now is carry out a simple simultaneous equation, find the value of a and the value of b, and then just sub it into the general formula they gave me, and that'll be my full marks. So in order to carry out my simultaneous equation here, I decided to eliminate my b's. I have a 2b on the bottom and a 1b on the top. So I multiplied the entire top line by minus 2, so that I would have a plus 2b and a minus 2b, and they'd cancel out. And then if I add my a's together, I get 2a. If I add my numbers together, I get 3. If 2a equals 3, just divide both sides by 2, and my value for a is 3 over 2. Once I get a value for a, I decided to sub back into the original equation, a plus b equals 3. Instead of an a, I sub in 3 over 2, and then when I worked it out, b actually works out as 3 over 2 as well. So once you have a value for a and a value for b, you can sub into the general formula. We knew at the start that the general formula was an squared plus bn. So now I can say it's 3 over 2n squared plus 3 over 2n, and that's my final answer for part D. Okay, for the last part of E, we're told that one of the patterns contains 4,134 matchsticks, and we're asked how many triangles are in that pattern. In the previous part of the question, we've worked out that the number of matchsticks is calculated as 3 over 2n squared plus 3 over 2n. We're now being told that the number of matchsticks is 4,134. So obviously that means that we can let the equation for the number of matchsticks equal to 4,134. What we can do now is we could find a value for n. Where n represents the pattern number. we could tell which pattern contains this many matchsticks. Once we know which pattern we're dealing with, we can work out how many triangles are in that pattern. Because we know the number of triangles in each pattern is n squared. So for example, the 10th pattern is 10 squared, or in other words, 100 triangles. So in this case, I just need to solve here to try and find the value for n. You should notice that you have an n squared, an n, and a constant. Or in other words, we have a quadratic equation. I'm going to bring the constant to the left-hand side, and my next goal is to try and eliminate the fraction. In order to eliminate the fraction, I'm going to multiply everything by 2. If you multiply the first two terms by 2, the fractions are gone. And if you multiply the last term by 2, you're going to get 8268 equals 0. So I have 3n squared plus 3n minus 8268 equals 0. Now you're not going to be asked to factorize a quadratic this difficult, so what you would hopefully have guessed is that you could divide everything by 3. Clearly we can divide the first two terms by 3, get 1n squared plus 1n, and if you try and divide this number by 3, you get 2756 equals 0. Now, you can use the minus b formula to solve this, but it's actually quite straightforward to factorize a quadratic equation like this. If you have a quadratic equation with a minus at the end and a 1 in the middle, it's very straightforward to factorize. The minus at the end indicates that the two factors need to have a difference of the middle number. And in this case, the middle number is a 1. So my two factors need to have a difference of 1. That means there are two numbers that can be multiplied by each other. They're only like 40 and 41 or 50 and 51. There's only one number between them, but they multiply to give me 2756. Now in order to find those two numbers, it's incredibly straightforward. You simply get the square root of 2756. If you get the square root of 2756, on your calculator it's going to be roughly 52.5. It's going to be around 52.5. Because if I round down and round up, that tells me what my two factors are. You get the square root of this number, you round down and you round up. 52 multiplied by 53 must give me 2756. They're the factors of this number that have a difference of 1. And now it's straightforward enough for me to factorize this. In this case, my two factors are going to be n plus 53 times n minus 52 equals 0. But obviously I need to solve this. So I let each factor equal to 0. I get n plus 53 equals 0, which means n is minus 53. Or else n minus 52 equals 0, which tells me n is equal to 52. Remember, I'm trying to work out which pattern contains 4,134 matchsticks. Clearly, the minus 53rd pattern does not contain any matchsticks. There's no negative patterns here. It must mean that the 52nd pattern contains 4,134 matchsticks. However, the question was, how many triangles are there? To work out the number of triangles, go back to what we did in the second part of this question. In the second part of this question, we worked out that the number of triangles is calculated as n squared. The first one is 1 squared, which is 1. The second one is 2 squared, which is 4. The third one is 3 squared, which is 9. The 52nd one is going to have 52 squared, which is 2,704. The 52nd pattern obviously has 2,704 triangles. And that's the full marks for the last part of this question. Okay, now question 9 here. This is a really thorough, really good question on integration. I want you to highlight this one. This is the question you revise on integration the day before your leaving cert, when and if it occurs. But this question is brilliant. This is by far the most thorough question I've seen on the applications of integration. And I know we gave this one to our leaving certs last year around this stage, and they really struggled with it. So let's go through this one, and I want you to really pay attention to this question. We're told that the acceleration of a particle is 1 over t squared plus 3t. We're told that the speed of the particle after 1 second is a half. And after 5 seconds, we're asked to work out the speed of the particle. Remember from your applications of differentiation that if you have the acceleration, in order to find the speed, you integrate. So I need to integrate the acceleration, and that will tell me the speed. So I'm going to integrate 1 over t squared plus 3t. However, it'll be a lot easier if I rewrite the 1 over t squared as t to the power of minus 2. So I'm going to integrate t to the power of minus 2 plus 3t. And when I do that, I'll know what the speed is. So remember, when you're integrating, you raise the power by 1 and divide by the new power. So t to the power of minus 2 is going to become t to the power of minus 1 divided by minus 1. 3t is going to become 3t squared divided by 2. I'm integrating here, but I'm not using limits. Because I'm not using limits, I have to add in a plus c. And I remember from last year, the vast majority of our students were forgetting their c there. And now, so that's the speed. I've worked out that that's the speed. And they told me in the question that after 1 second, the speed is a half. So if I sub in the information given there, I'll be able to work out what my c is. If I sub in s equals a half, I know that the speed is a half, and I can sub in t equals 1. So I just get 1 to the power of minus 1 over minus 1 plus 3 times 1 squared over 2 plus c. Now if I simplify this down, I just have a half here. All of these is just going to become minus 1. If you plug that into your calculator, you're just going to get minus 1. While on this one, you're going to get 3 over 2 plus c. Now here, 1.5 minus 1 is obviously just a half. So I get a half is equal to a half plus c. Now obviously the half on the left and the half on the right are going to cancel, and I'm actually just left with c equals 0. Which means if you forgot about your c, you're still going to get the right answer, but you wouldn't have gotten the full marks, because if you integrate without limits, you have to add in your plus c. So they gave you that piece of information so you could find c. And I just found out that c is actually 0. Which means the c is irrelevant, and the speed of this particle is actually t to the power of minus 1 over minus 1 plus 3t squared over 2. Now to answer the question, all I need to do is sub in t equals 5. If I sub in t equals 5, I'll find the corresponding speed. So once I've got my speed, I simply sub in t equals 5, and my speed, the corresponding speed, is 373 over 10 meters per second to the minus 1. There was nothing to indicate you had to leave it as a fraction, so if you left it as 37.3, then that's fine. You get the full marks either way. In A part 2, you were asked to find the average speed of the particle over the interval from 1 to 5. Remember that one of the main things we did in integration is probably the thing that has come up the most in the last few years in the Leaving Cert is the average value formula. To get the average value of a function, you integrate the function. If you use the limits b to a, you multiply by a fraction in front of it. So the average value of a function is 1 over b minus a, integrating the limits from b to a of whatever your function is. That's basically the formula for it. It's not in your maths tables, you just have to recognize it. If you're asked for the average of a function, that's what you do. So I need to integrate this. But before I integrate it, I'm going to make it a little bit nicer. I have this in a very messy way. If you have t to the power of minus 1, that's the same as having the t on the bottom. T to the power of minus 1, that's the same as t to the power of plus 1 on the bottom. And if you have a minus 1 here, it just makes the fraction minus. So the way I'm writing this, it's actually the same as just minus 1 over t. It didn't really matter in the last part of the question, but since I'm about to integrate this, I want to make my life a little bit easier. Then 3t squared over 2 is, I can't make that any nicer, so I'll just leave it as it is, 3t squared over 2. So that's the speed simplified down. And now I need to integrate the speed using the limits that were given. So it's relatively straightforward to sub in your limits. I have 1/4 outside, and my upper limit was 5. So everywhere there was a t, I simply subbed in a 5. Then a minus, and then everywhere there was a t, I subbed in a 1, I subbed in my lower limit. If I plug all of what's in my square brackets into the calculator, I got 60.3905, which if I multiply by 1/4, my final answer to 2 decimal places is 15.01 meters per second. Okay, let's have a look at B part 1 now. There was a load of information at the start of part B, so let's just take the bits of information that are relevant to B part 1. I've been given a function, a quadratic curve, that is 32 minus 2 times x minus 3 to be squared. They've drawn in a broken line that is y equals 14, and they've marked in the coordinates of A and the coordinates of B, the points where the function crosses the line y equals 14. And I've been asked to find the coordinates of A and the coordinates of B. I clearly know, I can see that the A and B, that the y value is 14. So on A, it's on the y-axis, so clearly that's the point 0, 14. And B is also on the same line, so I know its y coordinate has to be 14. So actually the only thing I don't know by just looking at it is what the x value of B is. In order to find this, I need to hone in on the fact that they're the points of intersection of the function and y equals 14. The function I've been given, I could view that as y equals 32 minus 2 times x minus 3 to be squared. To find the points where y is equal to 14, I would simply sub in y equals 14. If I sub in y equals 14, I'll get two different x values. One of them will be 0, and the other one will be the corresponding x value for B. So basically I'm just subbing in y equals 14, and now it's just basic algebra. I just need to find values for x. Okay, so I have my function, I let it equal to 14. What I decided to do next was to subtract 32 from both sides to get rid of the 32. And I got minus 2 times x minus 3 to be squared is equal to minus 18. I then decided to isolate the x minus 3 to be squared, so I divided both sides by minus 2. On the left I get x minus 3 to be squared, and on the right minus 18 divided by minus 2 is 9. Now in order to eliminate this squared, I got the square root of both sides. But I remembered that I wanted to get two different answers. So when I get the square root of 9, you take it as plus or minus 3. Remember, you can do that in any stage in maths. When you're getting the square root of a number, you can get two answers if it's relevant to the question. Here it is because I clearly need to get the 2 times where this function crosses the line y equals 14. So when I did that, I worked out that if I took this as a plus 3, one of my values is 6. If I took it as a minus 3, my value is 0. Clearly I already had that one. I already knew A was 0, 14, but now I know B is 6, 14. So to get the full marks for the first part of B, you would say that A is 0, 14, and you would say that B is 6, 14. Obviously you don't have to do it exactly like I did. You could have multiplied out your brackets. The easiest way of doing it was to follow these steps. Okay, in B part 2, we're asked to use the trapezoidal rule to get the area of the shaded region between the upper shaded region between A and B. Now, in order to do that, we need to accurately work out coordinates for f of x. So I plugged it into my calculator and I worked out a table that for f of x, working out values from 0 to 6, it would be 14. Obviously, I know the start of the function would be at 14. Then at 1, it would be at 24. 2, 30, 3, 32, then 30, then 24, then 14. So I've worked out the exact coordinates, the exact values here. That's the only way that we're going to be able to use our trapezoidal rule. Remember, the trapezoidal rule is we need the width of each section, and obviously they've told me the width of each section needs to be 1. So I need to go up 1, 2, 3, 4, 5, 6. And I also need the heights of each section. So I need the distance from here to the top, from here to the top, from this point to the top, the whole way along. I know that the bottom of the region I'm looking for is at y equals 14. I now know that one of the points up here is the point 124. 14 minus 24 is 10. So that tells me if the distance from here to here is 14, then obviously this first distance is actually 10. Because 14 and 10, that would get me to 24. Now, the second point is 230. So if the distance from here to here is 14, then the distance from this point to the top, that must be 16. Because 30 minus 14 is 16. So the distance from here to here is 14, and then the distance from here to here is 16. The same thing at 3, that 3 reaches 32, so it's the highest point. If it takes me to go from here to here, the distance is 14. That means that the distance from this point to the top is 18. Then once again, the numbers are the same as we go down. So these are the values that I actually need to use in my trapezoidal rule. So the key to this question was to accurately work out a table for your actual function so that I could work out what these heights were. Okay, the trapezoidal rule can be found in the area approximations, page 12 in your maths tables. And the trapezoidal rule is h over 2 times y1 plus yn plus 2 times all the other heights. Remember that the y's represents the heights, while h represents the width. Now the width we're using is clearly 1. We're going over in ones. So the width in this case is just 1 over 2. The width is 1, so I just have 1 over 2 here. y1 refers to the first height, and yn refers to the last height. The first height here is 0, Because remember, I'm only getting the area above the line y equals 14. So the first height refers to this one here. The first height is 0 because the first point, 0, 14, the point A is actually on the line. It's not above the line. So in that case, it's just a 0. The last height is also a 0. This point, because B is also 6, 14. So the first height is 0 and the last height is 0. The second height is 10, then 16, then 18, then 16, then 10, and then I'm back where I started. So it's going to be 2 times the second height, 10 plus 16 plus 18 plus 16 plus 10. You'll notice this is very similar to what we were doing in class a couple of weeks ago. So now you just plug that into your calculator and I'll get a rough estimate of the area of this shape. And if you plug all of that into your calculator, the area works out as 70 meters squared. Remember, I know my units because they referred to it as meters in the question. So now let's look at the next part of the question where we actually accurately find this area. Okay, in B part 3, we're asked to now accurately find the area of that region. Remember that in B part 2, if we use the trapezoidal rule, it's only an estimate of the area. So our answer to B part 2 was 70 meters squared, which means our answer to B part 3 should be similar enough. It should be close enough to 70. In order to get the area of the shaded region, the area above AB here, what we need to do is use integration. If we integrated the function f of x using the limits 0 to 6, I will get the area of everything between the curve and the x-axis. So I'm going to integrate from 0 to 6 and I'm going to end up with the area, everything from here, everything under the curve from 6 to 0. Obviously I don't want all of that because I don't want this region in the middle. This bit here is a rectangle, so I don't want to include the area of the rectangle. What I'm going to do is integrate the function and use the limits 6 to 0 and then subtract the area of this rectangle and I'll be left with the shaded region on the top. Remember that to get the area of a rectangle it's simply length multiplied by width. The width in this case from 0 to 6, obviously the width is just 6. And then the other dimension goes from, it starts at 0 and goes up to 14. So obviously the other dimension is just 14. 6 multiplied by 14 is 84 meters squared. So I know that this area is 84 meters squared. I'm going to integrate the function and get everything between the curve and the x-axis. And then subtract this bit from that answer, subtract the 84. And that will leave me with the area between AB, between this line y equals 14 and the curve. So before I integrated my function f of x, I decided to multiply it out and group it and rewrite it as minus 2x squared plus 12x plus 14. At that stage, when my quadratic is in a nicer format, I decided to integrate the quadratic from the limits 6 to 0, giving me all of that region we discussed in the previous graph. When you integrate the quadratic, you get minus 2x cubed over 3 plus 12x squared over 2 plus 14x, and my limits are 6 to 0. So I rewrote that with a 6, and then I put a minus between them, rewrote it with a 0. When you plug all of this into your calculator, you get 156. And this just works out as 0 anyway. But the area under the curve was 156. What I then did was subtracted the area of the rectangle that we worked out in the diagram. 156 minus 84 tells me that the actual accurate area of that shaded region is 72 meters squared. Makes a bit of sense. It's quite similar to the answer we had in B part 2, which was 70. The trapezoidal rule was slightly off because it's an estimate, whereas this is bang on, this is 100% accurate because we're using integration. So in part B we worked out that the amount of area that needed to be excavated above the line y equals 14 was 72 meters squared. We're now told that an alternative proposal is to just excavate the area above the line y equals 24. And if that is the case, we're asked what is the percentage reduction. So I need to get the area of between the curve and the line y equals 24. And when I do that, I need to work out how much smaller is it than my answer to B part 2. And then get that as a percentage. So there's a good few steps to this one. We basically just have to follow the same steps as we did in part B, but it was broken up for us in part B. What I need to do first is I need to work out the limits. I need to work out when does f of x, the quadratic, intersect the line y equals 24. In order to do that, we're going to do basically the exact same thing as we did in B part 1. We're going to let the quadratic equal to 24. And when we solve this one, we're going to end up with two values for x. Presumably those values for x, or they will be between 0 and 6, because obviously it has to be, maybe it's going to be 1 and 5 or 2 and 4, but it's definitely going to be between 0 and 6. When I do that, I'll then know what my limits are. Then what I want to do is integrate the curve. I'll integrate the curve using those limits. Let's just imagine for a second, when we've worked out these limits, let's say that that's a 1 and that's a 5. When we do that, when we integrate the quadratic from 5 to 1, we are going to end up working out everything between the curve and the x-axis. So I'm going to integrate and I'm going to get that whole thing. And obviously what I want to do then is I want to get the area of this rectangle and subtract it. So that's all the steps that we're going to carry out in order to get this area. Let's just do them one at a time now. The first one we're going to do is identify, we're going to try and work out when is f of x, the quadratic, equal to 24. So again, this is very similar to B part 1. We let our quadratic equal to 24. What I did next was I subtracted 32 from both sides, and I got minus 2 times this bracket equals minus 8. I then divided both sides by minus 2, and I got x minus 3 squared equals plus 4. Now I got the square root of both sides, but I know that I need two answers. The quadratic crosses the line twice. I can see it on my graph. So I got two values for 4. I said it could be plus or minus 2. In the scenario where x minus 3 equals 2, x works out as 5. And in the scenario where x minus 3 equals minus 2, x works out as 1. So in fact, those limits that I used in the example, they're the actual limits. I'm trying to get the area between the curve and the line y equals 24, use it from the limits 5 to 1. So what I've done here is I've jumped straight into my integration. I want to integrate the function from 5 to 1, the quadratic curve minus 2x squared plus 12x plus 14. If I integrate that from 5 to 1, it tells me everything between the curve and the x-axis from the limits from x equals 5 to x equals 1. So I integrated the same as last time. This time, rather than subbing in 6 and 0, I'm subbing in 5 and 1. When I subbed in 5, I got 410 over 3. And when I subbed in 1, I got 58 over 3. And when I subtract the lower limit from the upper limit, I got 352 over 3. So the area between the curve and the x-axis is 352 over 3. Let's have a look at what that looks like on a diagram. So when I plug that into my calculator, I worked out that the area of this region is 64 over 3 meters squared. That's the area between the curve and the line y equals 24. And the question was, work out the percentage reduction. So in B, the last part of B, we worked out that the area between the curve and the line y equals 14 was 72 meters squared. Whereas this area is only 64 over 3 meters squared. And I'm looking for the percentage reduction. So obviously the first thing I need to do here is to work out how much smaller is this answer than my answer from B part 3. So from here on out, the maths is quite straightforward. We need to work out the percentage reduction. But obviously, first of all, I want the actual reduction. The original answer was 72, but when we moved the line up, the area was 64 over 3. So if I subtract the answer for C from the answer from B, I end up with 152 over 3. That is the actual reduction in meters squared. And I'm looking for the percentage reduction. The percentage reduction will be the amount it reduced by divided by the original area. And I'll multiply that by 100 over 1. If you plug that into your calculator, the percentage reduction in the cross-sectional area that needs to be excavated is 70.37%. Question asked you to leave your answer to 2 decimal places, so that's it. So I hope all of this made sense. Over the next few weeks, I'm going to try and give you a few more tests because it's your best form of revision. I'm sure you found a few things there that you need to brush up on. If you should try and identify topics that you really struggled with, and if you can identify that, try and do as many exam questions as you can on that topic over the next few weeks.